We are going to use a ratio table to solve the following problem. The ratio of boys to girls in class is 4 to 5. How many students are in class if there are 120 boys? A ratio table is used when we want the students to use kind of intermediate steps in order to develop equivalent ratios. In this problem, they're going to be able to use many strategies, or I'm going to show you many strategies that they can use within their ratio table to get to the answer of how many students are in class if there are 120 boys. So initially the students would set up a ratio table, and I just quickly have them, draw some lines, and we can add more if we need more. And since I go to my problem, I'm going to see that the ratio is comparing boys to girls. So I'll put B on top for boys, G on bottom for girls. And I know the ratio of boys to girls is 4 to 5 because order matters. So 4 to 5. And again, from my problem, I know that my target number is going to be 120 boys. So I'm going to go ahead and put it out here a little farther. So I'm going to use some intermediate steps to show you how a ratio table works in order to find out how many students in class if there's 120 boys. The students can use different strategies. They can double things, they can divide things by 2, they can multiply by any number, they can divide by common factors. They can multiply by 10. They can add columns when they have 2 columns together, or they can subtract columns. So we can do a variety of things to develop the proportional reasoning, and that's exactly what this ratio table is trying to do. So I'm going to take you through some of the very intermediate steps. We know that if we do 4 times 30, we get to 120, and 5 times 30 makes 150. So, but maybe the students don't see that. So what they can do is they can double it. So this would become 8 because double 4 makes 8, double 5 makes 10. Then I'm going to go ahead and double 8 again to get to 16, and I'm going to double 10 again to get to 20. These are all equivalent ratios. So I'm going to go ahead and double again, and I'm going to get 32 and 40. Again, another equivalent ratio. So then I'm going to double another time here and do 64 and 80. And I'm just going to keep doubling to see where I get. Then if I go to 64 doubled makes 128, and 80 doubled makes 160. So what I can see right now is I would use my number sense. I'd see, okay, 128 is larger than my target. However, I do have 2 columns. If I take 128 minus 8, I get to my target of 120, so I have to do the same thing to the bottom. So 160 minus 10 is 150. Now in this particular problem, if they set it up as boys to girls, it says how many students are in class. So the kids have to have a good understanding that in a class, classes are made up of boys and girls, so they would actually have to add this together. 120 plus 150 makes 270 students. And we would label our answer here. So there's another way to set up this ratio table, and there are many, many different ways to work the ratio table. This was just the very simplistic strategies of working it. Doubling, timesing by 10, they could have gone to 40 and then 50 on the bottom, and then saw 40 times 3 makes 120, 50 times 3 makes 150. Many different ways that you could do it, and this really lends itself to some very good conversation with the kids. Okay, I'm going to start another ratio table, and it says how many students are in class if there are 120 boys. So I really don't need the girl ratio. So I'm going to go ahead and draw my ratio table again. And this time I'm going to compare boys to students. So if I have a little better understanding of ratios, I know that I only need boys to students, and I know there's 4 boys out of 9 students, which means that because I added the 4 girls and 5 boys, there's 9 students altogether. So I still have a target of 120 boys. So I'm going to use some different strategies now to solve this problem. So I'm going to go ahead and do my times 10, and I'm going to get 40, and I'm going to get 90. Okay? And so maybe I don't understand that 40 times 3 makes 120, 90 times 3 makes 270. I'm going to go ahead and double it. So I get 80, and I get 180. So right here, if I take 80 and I add it to 40, I get 120. I added those 2 columns together, so I have to do the same thing on the bottom. I have to add 180, and I have to add 90 to get to 270. And in this ratio table, There you can see that I labeled the students, so it means 270 students. I'll put S for students. Here's another problem that can be used to solve, use a ratio table to solve. I'm going to go ahead and set up my ratio table. And this time in my problem, I'm comparing pounds to dollars. So off to the side, I'm going to do pounds, and then I'm going to do dollars. And it's 2 pounds to $5. And my target is 15 pounds, so 15 is going to go on the top because that's my target. At this point in time, the way that we've learned it before, you'd see 2 times, I don't know, goes into 15, and that's what most students, they would not know what that was. So I'm going to have to use my ratio table strategies to solve. So I'm going to go ahead and double and get to 4, and double and get to 10. I'm going to double again and get to 8, and double again and get to 20. I'm going to double again and get to 16, and I'm going to double again and get to 40. At this point in time, I can see I'm 1 away from 15, so I have to make 1. So I'm going to go back to the beginning and divide 2 to get 1. So 2 divided by 2 is 1. 5 divided by 2, and what I try to get the students to think about is money. If they had $5, what would be half of $5? And they can always tell me $2.50, so 2.5. So now I can take 16 minus 1 to get 15, and I can do 40 minus 2.5. So if they don't know what 40 minus 2.5 is, they can easily do this in their head. If you say 40 minus 2 is 38, but I have to go 0.5 more, my answer becomes 37.50, so $37.50 for 15 pounds of candy.